Jai Hind everyone. I am Shruti Jain, Assistant Professor, MCA Department, Ajay Kumar Garg Engineering College. The topic that we are going to discuss today is Introduction to Relational Model. The topic is covered under the Database Management System subject. The subject code is BMC 204, and the students the target students are MCA first year, second semester. So let's understand what data models are. So if we talk about the data models, these are the modeling of the data description, the data semantic, and maintaining the consistency of the data by applying maybe some of the constraints or something. So the data models, they provide a kind of a conceptual tool to describe the design of the database at each level of data abstraction. Like when we abstract the data, we have the conceptual layer, we have the physical layer, and we have the layer on the logical layer on which we can extract the data. So there are the different types of data models that we have available for describing the data. Like we have the object-based logical model, which talks about the ER diagrams. Then we have record-based logical models, where we have the hierarchical data model, the network data model, and the relational data model. The data model that we'll be discussing today is the relational data model. So if we talk about the relational data model, it represents the database in the form of collection of various relations. Relations here basically represent the tables in which the data is stored. The data in relational model is stored in the forms of rows and columns. Like if we talk about the relational data model, we have a relation that is a table named employee, suppose, and we have multiple columns like employee ID, the name of the employee, and we have certain records of the employee, like employee ID with one name is ABC, and he has some of the records. Then we have an employee ID 2 with name XYZ, and they'll be having some of the records. So this is a kind of a relational model where we are storing the data in the form of rows and columns, and they represent the real world entities. This is not something which does not exist in the world. These are something which already exist in the world, but we are storing them in the form of the tables. So this relation refers to a table of various values, and every row present in the table, they happens to denote some of the real world entities or the relationships. Relationships as in, like if I talk about the person with the name ABC, this person would be having the employee ID, he will be having some age, he will be having the contact number. So he will be carrying some of the properties or the attributes. So they have some of the relation with each and every attribute that is there in the table. The names of the tables and the columns, they help us to interpret the meaning of the values that are present in every row of the table. This data gets represented in the form of set of various relations. It is not there that the whole of the data is stored in one table. We have multiple tables in which we store the data. So if we look into some of the characteristics of it, the first one is the data is viewed as existing in two-dimensional tables that are known as the relation that we have already seen. It has the rows, the number of rows, and the columns. A table consists of the unique attributes that are the columns and the tuples that are the rows. The rows here could be called as the tuples or maybe records, and the columns over here represent the attributes. Sometimes a value to be inserted in a particular cell may be unknown and it may have no value. This is represented by a null. For example, we may have a person whose contact details does not exist or who does not carry a phone, though that is not possible in today's world. But let's assume that there is a person who does not carry a mobile phone or does not have any contact number. So in that case, this field would be blank and that would be filled with the null value. So null value is such value where we do not have any value entered into that particular field. But it is not same as 0 or blank. 0 is something with a value 0. They have a value, but that value is 0. Null means we do not have any value at all. So relational database is any database whose logical organization is based on the relational data model, and RDBMS is a database management system that manages the relational database. So we have some of the characteristics of the relational model. The first characteristic is the values are atomic in nature. Atomic in nature means in one cell we'll be having only one value, like the age of a person. Age of a person would be a single value, that is atomic value. In case a person is having multiple contact numbers, in that case we'll have multiple columns for it. One column can contain, or one record or one cell can contain only a single value, that is the atomic in nature. The composite and multi-valued attributes are not allowed. Each row is unique in nature. We cannot have multiple rows of the same data existing in the relational model. So we have certain constraints that we'll be looking forward, on the basis of which we clarify that only one record at a time, if there are multiple records, all the records are unique in nature. The sequence of column is insignificant. It does not matter which column is existing first and which column is written at the next. The sequence of the columns does not matter. Similarly, the sequence of the rows does not matter. Each column name should be unique. We cannot have two column names with the same name. In case we have two columns for the contact number, we'll be saving it maybe like contact number 1, contact number 2, or maybe mobile number 1, contact number 2, something of that sort, which identifies that there are two different unique columns existing with different separate names. All the values present in a column hold the same data type. Every column will have all the values in that column with the same data type for which we are creating that particular column. If suppose I have a column, like we have the customer ID, this customer ID is suppose of the number data type. So it will be storing all the values in it with the number data type. There cannot be any value which is a non-integral value or any string value. It will not accept those values. The column sequence is not significant, the row sequence is not significant. Like here we have a relational model where we have the number of attributes as 3 and number of tuples as 4. The number of tuples can be read as number of records, rows or tuples, and it is also known as a cardinality of the relation. Similarly, the number of attributes, the columns or the fields, is also known as the degree of the relation. So we have 1, 2, 3, 4 as a cardinality of the relation and 1, 2, 3 as a degree of the relation. Some terminologies, some of them we have already discussed. We'll just move forward with those, and the rest of the terminologies we'll be discussing. The first one is the attribute, field or column. As we just discussed, attribute or field or column is basically the column names, the number of columns that are there in the relation. Like in this, we have 1, 2, 3, 4 and 5. 5 columns are there. Those are the roll number, name, address, phone and age. Relation schema. Relation schema is a schema that defines the structure of the relation. The overall schema, which it represents the name of the relation with its attributes. Like if I have this as the relation name as the employee, so the relation schema would be the employee, or maybe if we look over here is a relation schema for student, and the column names or the attributes would be the roll number, name, address, phone and age. If the schema has more than one relation, it is known as a relational schema. Tuples or rows or records are the number of rows that are there or the rows that are there in which we store the data. Here we have 4 rows with roll number 1, name Ram, address at Delhi, phone number and the age as 18. The next thing that we have is relation instance. The relation instance is at a particular instance, the number of rows that are there in the relation, that is the relation instance. At a particular point of time, the number of rows that are there in a relation is a relation instance. It may increase or decrease after a certain point of time. So if suppose I am identifying the number of rows at 2 p.m. So at 2 p.m. the number of rows that are there is the relation instance are at 2 p.m. So suppose, but it may be a possibility that at 2:1 we may have some of the records added to it. Degree, the number of columns in a relation is known as the degree of the relation. Like here we have 5 columns, so we have the degree of relation as 5. Cardinality, the number of rows in a relation, that is, here we have 4 rows, so the cardinality of the relation over here is 4. Now we'll discuss some of the anomalies or some of the irregularities or something unusual that normally that does not allow us to get the expected result. So the first anomaly that we have is the insertion anomaly in the referencing relation. Insertion anomaly in the referencing relation means that it says that suppose we have 2 tables. In case I am trying to add some of the value in the referencing table, that will not be allowed if it is not referenced in the reference table. For example, suppose I have one table as employee and this employee has EMP ID, name and the department. The other table that I have is the department table with the department ID and the department name. Right? Now, in this, suppose this is department ID. Here I have 01, 02, 03 with one department as maybe IT, CSE, sales. These are 3 departments that are already there, and there are certain employees with all 3 departments over here. Now, in case if I want to add one department ID 4 over here, where the reference of the department 4 is not available in the department table, in that case, I will not be able to add, or I will not be able to allow, I will not be allowed to enter any of the record for this employee with the department ID 4, because we do not have any reference of it existing in the department table. So that is the insertion anomaly. In the insertion anomaly, in case we do not have any value in the referenced table, in that case, we will not be able to add or insert any of the value with that particular in the referencing table. So, if we read the statement over here, so it says, we can't insert a row in the referencing relation if the referencing attribute value is not present in the referenced attribute value. So, this is the referencing table, this is the reference table, because the 04 is not present over here. We cannot add any or we cannot insert any of the value, any of the record in this table. The next one is deletion or updation anomaly in the referenced relation. Similarly, if we take the same example over here, in that case, if suppose I want to delete any record of this, if I want to delete this department from here without deleting the employees who are already existing in this department ID, I cannot do this. I cannot delete this record until and unless all the employees from this department are already deleted. If there exists a single employee with this employee ID 03, in that case, I cannot delete this record. Similarly, I cannot update this 03 to 010 maybe until and unless this 03 is, if this 03 is present over here. That means both the things, deletion or updation, needs to be done simultaneously, and I cannot do it just by deleting from here and without deleting from here. So that is the deletion or the updation anomaly. Let's read it. We cannot delete or update a row from the referenced relation if the value of referenced attribute is used in the value of the referencing attribute. We cannot delete this until and unless this is deleted, or if there are records with this particular value in this, I cannot delete the record from here. We have on delete cascade. What on delete cascade will do? It will delete the tuples from the referencing relation if the value used in the referencing attribute is deleted from the reference relation. So on delete cascade will delete from both the relations simultaneously. It will not happen that from one of the relation the data is deleted and it exists in the other relation. On delete cascade will delete from both the tables simultaneously. Similarly, we have on update cascade. On update cascade will also update the referencing attribute in the referencing relation if the attribute value used by the referencing attribute is updated in the reference relation. That means, again, if the updation is to be done, the updation from on update cascade will update the values in both the relations simultaneously. Otherwise, it will not do any of the changes in any of the tables. The next thing that we have are the types of keys in the relational model. We have certain keys. Keys basically refer to the columns or the attributes that we are talking about in the relation. So, we have different types of keys on the basis of which we are able to identify a record in the relation. Because it may be a possibility that a record can be stored multiple times. As we have seen that they say that each record is saved with different values. They are unique in nature. So, these keys help us to maintain that integrity, and it has some constraints due to which we cannot store same record multiple number of times in a relation. So, the first type of key that we have is the candidate key. The candidate key is a minimal set of attributes that can uniquely identify a tuple, that is known as a candidate key. So, it has certain conditions. The first one that we have is it cannot contain a null value, it must contain a unique value, and it is the minimal set of attributes which identify a record. Also, it is a key with no repeated data. The data is not repeated. And every table must have at least a single candidate key in order to identify a record. Until and unless we have a unique values in one of the attribute, we cannot identify the records in the table. It may be a possibility that a table can have multiple candidate keys, but it must have at least one candidate key in the table. Candidate key must contain the unique values and it cannot contain a null value. For example, we have a relation employee where we have the employee ID, employee name, employee address, passport number, license number and SSN. So, as we know that every person would be having a unique passport number, license number, SSN. Also, every employee will have a unique employee ID. So, employee ID, passport number, license number, SSN, these all are the candidate keys. So, candidate key, we can have it like this also, unique email. In that case, we can say that this is also a candidate key, where we say that it is unique in nature and it will be a not null value. The next one is the primary key. The primary key is a candidate key which we consider as a primary key. Like out of multiple candidate keys, we are able to find out one value or one key which we call as a primary key. It has all the features that are there for the candidate key. That is, it is a unique key, identify only one tuple because we say that it is unique. It does not have a duplicate value, that is, it has a unique value. It cannot be null and they are not necessarily to be a single column. More than one column can also be a primary key for the table. So, if we look over here, we can take the employee ID or passport number or license number or SSN number, any one or a combination of keys as a primary key. So, in this example, like we have taken the employee ID as the primary key The rest of the candidate keys are not selected as a primary key. So in a bunch of the candidate keys, we can select one or multiple primary keys to identify a record uniquely. The query would be, suppose I am creating a table named student. So that would be create table student, the student ID with its data type int, and will be writing the keyword primary key in order to make it as a primary key. As soon as we put any of the attribute as a primary key, these features automatically come there, that it is a not null value. It cannot contain the duplicate values, that is, it is unique in nature, and it can identify only one tuple at a time. The next set of keys that we have is the super key. The super key are those keys which uniquely identify a tuple in a relation, but it can have null values. So in candidate key and the primary key, we have seen that they uniquely identify the records, but they cannot be null. But when we talk about the super key can uniquely identify a tuple, but they may also contain the null values. So super key values may also be null. It is a group of single or multiple keys which uniquely identify the rows in a table. Adding 0 or more attributes to the candidate keys may generate a super key. Because if we talk about the candidate key solely, then in that case we cannot have those null values. But in the candidate key, if we add some of the attributes which are not candidate keys, in that case we can generate the super key. For example, if we look over here, employee ID we have already seen is the candidate key. So candidate key means it will be a not null value and uniquely identify record. But if I consider this employee name also, in that case, because employee names can be same, we can have multiple people with the name Rahul. In that case, these two become the super key. Employee name could be null also, like if we don't want to mention the name of a person, we only work with the employee ID. In that case, the employee name could be null. So here we have the addition of these three. The primary key is a key which is the subset. If we talk about the superset, the super key is a superset which has the null values and null and unique values. It uniquely identifies a record and it may contain the null value. When we remove this null constraint, so we have not null. When we remove this not null constraint and we keep this unique constraint over here, then it becomes a candidate key. So candidate keys are not null but uniquely identifies a record. Out of these candidate keys, when I select some of the keys, those keys become the primary key. The rest of the keys remain in the candidate key area over here. The next one that we have is alternate key. Alternate key is the candidate key which is not a primary key, that is an alternate key, like we were talking about here. In this case, if this is the primary key and these were the candidate keys, then passport number and SSN becomes the alternate key and this key becomes the primary key. So all the keys which are not primary keys are the alternate keys. These are the secondary keys and may contain 2 or more fields to identify 2 or more records. These values are repeated, like here we have the employee ID which is selected as a primary key, and passport number, license number and SSN, here are the alternate keys which combined together makes the candidate key, the set of candidate keys. The next one that we have is foreign key. Now foreign key is a key which is used to fetch the data from 2 different tables. If I want to find out the data from 2 different tables, suppose I have one table as the employee and the other table is suppose department, and I want to fetch the data from both the tables, then I would be needing one key or one column which is same in both the tables, which exist in both the tables. So this is, suppose the department ID is the primary key for the department table, and because it exists over here, then this column over here is a foreign key column. This foreign key column will be able to fetch the data from the department table. Suppose I want to find out the employee name and the department name of a particular employee. So I'll be needing both the tables. Both the tables will be combined together or joined together with this particular foreign key column, that is the department ID. So we have this as a sample query where we have a table courses that is generated, that is created with course ID as a primary key and course name with the data type varchar. We have one more table created, that is enrollments, which have enrollment ID as a primary key. When we want to find out, when we want to join these two, we need a common column, that is course ID. That course ID would be referred to as the foreign key with course ID as a column over here, which references the courses table with the course ID. So foreign key of this table references the course ID of the courses table. So this is how we write the foreign key. The last one that we have is the composite key. The composite key is the combination of keys which uniquely identify all the records of a table. Because that we need composite key because sometimes what happens that we cannot find out the unique data from a single table or from a single column. So in that case, we need to combine two or more columns or attributes together in order to fetch the unique data. So this composite key, this acts as a primary key if there is no primary key in the table. Two or more attributes are used together to make a composite key. Different combinations of attributes may give different accuracy in terms of identifying the rows uniquely. So it depends. We need to be very careful on how we select those keys in order to fetch the data from a relation. So we have the query for this. We have, suppose we have a table employee with employee ID, employee role, project ID, and we combine all these to form a composite key. So the composite key, when we are working on the table, because we need to create a primary key, we'll have a course registration table that is being created with primary key as a combination of two, that is student ID and course ID. So this is the composite key which is considered as the primary key, maybe because we do not have, we cannot identify a record uniquely either from student ID uniquely or course ID separately. We'll be continuing with relational data model in further lectures.